Alright, welcome to your first college algebra trig flipped video. Today our topic is going to be talking about the real numbers and their subsets. Now, something you should know about these videos. First of all, I understand that the pen writing is a little bit annoying, but I can't do anything about it as of right now. Second thing, in your notes packet, on the first page you'll see it says definitions and properties. That's going to be some information that I'll refer back to. But then if you flip to the second page, it should say Unit 1 Notes and Examples, and then you have some space to take notes as I'm talking through the video. So we'll kind of flip back and forth between those two things. So today's video is mostly about understanding some vocabulary and making sure that you review your different subsets of the real numbers. We're not going to worry about imaginary numbers yet. That's going to come later in the course. So first thing, definition of natural numbers in your packet says they are all of the counting numbers. So, numbers that you would use to count with. Go ahead and take a second, see if you can write down from this list, A through P, which of these things would be counted then as part of the natural numbers. I'm going to ask that you pause your video and try to write them down, and then unpause whenever you are ready to check your answers. So go ahead and pause now. Alright, so hopefully you came up with 3 and 1 and 12. Those should be your, and 1,503,456. These four are counting numbers. When we start counting, we start at 1 and then 2, 3, 4, etc. So for characteristics, you can write this in if you want to, but it's also underneath your definitions on that first page. We're going to talk about these as the counting numbers. Alright, so that's our smallest subset. We're going to get a little bit bigger, and now we're going to talk about the whole numbers. Well, if you look at your definition on your first page, the whole number is going to be all of the natural numbers, including 0. So once again, when you're ready, you can go ahead and pause your video and then check your answers after you've written down all of the whole numbers. Alright, well, like we just said, it's going to be all of our natural numbers, which are all of these, with the addition of 0. So our characteristic is going to be natural numbers and 0. Alright, getting a little bit bigger yet, we're going to now talk about the integers. And the integers are going to be all of the whole numbers, so what we just talked about, with the addition of the negative natural numbers. So, thinking about this list, we want to talk about the whole numbers with the addition of the negative natural numbers. Go ahead and pause your video and then check your answers when you're ready. Alright, so as you can see, we have all of our whole numbers that we had on the previous slide, and then we added to that all of the negative natural numbers that existed in this list. So, we're going to say whole numbers and the negative counting numbers. So, negative 1, negative 2, negative 3, negative 4, etc. Alright, getting even bigger still, we are now going to talk about the set of rational numbers. Within the word rational, you should recognize the word ratio, which is the comparison of two things. Usually we write that with a colon separating, or sometimes we'll write it as division, okay, but you're comparing one number to another. Specifically with rational numbers, we're going to say that they are the ones that can be written as a ratio of two integers. So integers was our previous set, negatives, zeros, and positives that you can count. So we're going to start putting those in a comparison to each other, and that creates our set of rational numbers. So go ahead and take a second, see if you can list out all of the rational numbers that exist from this list. Alright, so rational numbers are going to be everything except for A and I for our list purposes. Now, some students just jump to the conclusion that if it's a rational number, it should be written as a fraction. Well, that's one way to think about it, but a lot of numbers can be written as fractions. For instance, negative 7 is the same thing as negative 7 over 1. But the way that we looked at it, it was just negative 7, and that's okay. 3.14 is the same thing as 314 compared to 100. And even this decimal right here can be seen as 1 compared to 10 million. Okay, so yeah, they can be written as actual fractions as you see them, but sometimes there will be other things that you can write as a fraction if you take a minute to rewrite the form. So we're going to say comparison of two integers. Alright, well then that leaves us with the irrational numbers. And if a number is not rational, then it makes it irrational. So from our list, that should include the square root of 5 and pi. Another way to think about irrational numbers are going to be those that cannot be written as a comparison of two integers, right? That's the opposite of rational. But also, they have a decimal that goes on without repeating in any sort of pattern. So pi, as we know, goes on forever and ever, but it does not ever repeat itself. That's what makes it irrational. Likewise, the square root of 5, the square root of 2, the square root of 3, a lot of the square roots end up being irrational numbers as well. We'll also learn later about an irrational number called e, which is very important in the mathematical world. So, characteristics, well, it sounds silly, but they're not rational. Now, the number, let's say 8/3, could be written as 2.666 over and over and over. And now that decimal does not end, but it could have been written as a fraction. So even though this decimal is going on forever, it still counts as a rational number. Alright, so then that brings us to the set of real numbers, which is a very common domain that we talk about with functions. So all of the real numbers include rationals and irrationals. So these were all of our rational numbers. These were our these were our irrational numbers. Therefore, all of the numbers that we have labeled A through P are considered real numbers. Now, real numbers have no imaginary parts. If you remember from previous classes, imaginary numbers involve I. Okay? So when we talk about the real numbers, we don't have anything with imaginary roots. And so when we talk about solutions to an equation being real numbers or the domain being real numbers, we're really just focused on everything that doesn't have that imaginary part to it. Alright, so the last thing I want to do is show you a quick diagram of how you can think about these sets inside of each other. So first we had the natural numbers, which was a very small set. And then we added to that the 0, which then created the whole numbers. Then we added to that all of the negative natural numbers, which created the integers. Then, I shouldn't use purple, I already used it. Then, we expanded even further to create the rational numbers. Then we have this kind of side subset over here. That was the irrational numbers. Okay? And all together, these things make up the real numbers. So when we talk about a domain being real numbers, we're talking about rationals and irrationals and all of their different subsets.